So guys, I need you to turn your papers over to the back side because today we're going to do a review activity on circumcenters, incenters, and centroids. So first I want you guys to write this down on the back side. I'm doing an upside down capital T for perpendicular. Okay, so if we have our perpendiculars, our perpendicular bisectors of a triangle, we know that they're going to meet in a point of concurrency called the circumcenter. Every single triangle has exactly one circumcenter. I want you guys to save some space and slide down quite a bit, so maybe like 2 or 3 inches down. And we're going to draw an angle symbol and write the word bisectors. Because it's also true that for every triangle, its 3 angle bisectors meet at a point of concurrency called the incenter. Okay, and then we're going to slide down again about an equivalent amount of space, and we're going to write the word medians. Because it's also true that every single triangle has 3 medians, and they meet at a point of concurrency called the centroid. Now, we also study the orthocenter, and that's where our altitudes of a triangle intersect, but that's not my focus for y'all's actual unit exam or your SMART goal. Your SMART goal was over circumcenters, incenters, and centroids, and so we're going to review those concepts today. What I want you guys to do is I want you to use your compass, and I want you to slide your slider in as close as possible to the center of rotation, and you're going to make a small circle here in between the words circumcenter and incenter. So just using your pencil, make a small circle. I just used a pencil, and I did not do a very good job constructing this, but okay. And then I want you to actually slide over to the right a little bit and make another small circle. I'm going to actually slide this down so I have better space. Oh man, mine don't look too good. These compasses are not the best, but you should have 2 small circles. Okay. What I want you to do with the first circle is I want you to plot 3 points on your circle in a way that will allow you to create a triangle. Okay, so I'm going to go ahead and just plot a point up here. I'm going to go down to the bottom left and over to the bottom right. Okay, so plot 3 points on your circle, kind of similar to how I've done here, and I want you to use a straight edge to connect those points and construct a triangle.
Should the 2 circles be the same size?
Yes. I mean, I guess it doesn't really matter though. They don't have to be. We're just doing like informal stuff right now.
Did you just plot the points wherever?
Yep, wherever you want. Yeah, you plot the points just wherever you want. Okay. All right, then I'm going to do the same thing with my other circle. I'm going to plot some points, and I'm going to connect my dots. Now, remember, a circumcenter, that is the point of concurrency of a triangle's 3 perpendicular bisectors. What does it mean to have a perpendicular bisector to a side of a triangle? What does that mean? What does bisect mean? It's going to cut it in half. What does perpendicular mean?
It's perpendicular.
What does that mean?
They make a 90-degree angle.
They make a 90-degree angle. So we know that the circumcenter, and guys, the circumcenter is actually that center of our circle. And I wish I would have marked it before I moved this, and I didn't, but it's okay. But we know that we're going to have perpendicular bisectors. So on the side of my triangle, I'm just picking one side here. I'm going to approximate what that midpoint would be. So I'm they don't have to be exactly the same. It's okay if yours aren't. But what I do need you guys to do now is I need you to go ahead and plot a midpoint to one side of your triangle. We know that by definition of a midpoint, it is bisecting the side of the triangle. So go ahead and indicate that that is happening. Now we have perpendicular bisectors. So we've got that bisecting nature. I'm going to go ahead and just kind of eyeball a perpendicular ray coming out of that side. So I just kind of, I guesstimated it. I just tried my best to make it 90 degrees. We're not actually doing true constructions here. And I'm going to draw a right angle. Okay. Okay, guys, so I'm going to actually repeat this process for each side of my triangle. I am going to create perpendicular bisectors. I'm freehanding it, so it's not going to be perfect, but I'm going to go ahead and rotate my paper around, and I'm going to look at my other side. I'm going to place my midpoint to this other side to the best of my ability. I know that by definition of midpoints, it's going to bisect the side of the triangle into two congruent parts. And because we have a perpendicular bisector, I need to try my best to construct a ray that is perpendicular to this side. Make sure you're keeping up with me on this, because when you work for the next 2 days by yourself, you're going to want this to reference. Okay? And now I'm going to rotate one more time and repeat this process with that remaining side of the triangle. I'm going to, and guys, we're freehanding, so it's not going to be perfect. But I'm going to go ahead and plot this midpoint. And I'm going to show that, hey, by definition of a midpoint, this side is being cut into two equal parts. And here's my perpendicular ray. And there is a point of concurrency that has to happen. That is actually the center of my circle. And that center is the circumcenter. Okay. So those three perpendicular bisectors, they should meet, or actually they would always meet if they were constructed appropriately at a point of intersection called the circumcenter. So this is one relationship about circumcenters that we know of. I also want you guys to make another relationship. I'm going to try my best to plot the center of the circle in this other figure that we've drawn, and I want you to as well. So I want you to try to plot the center of the circle.
Mine looks silly because I did two different triangles.
Okay. All right, guys. So your three perpendicular bisectors, I'm just kind of recapping. They would intersect at a point of concurrency called the circumcenter. And the circumcenter is the center of the circle that is circumscribed about the triangle. But we have right now, we have a triangle that has a circle that has been circumscribed about it. Circum means around, okay, like circumference. Okay, but we have a circumscribed triangle. That's what's happening. In your other figure, I want you to try your best to plot that center of the circle to the best of your ability. Okay, and then we're gonna create radii. That's plural for radius. So going from the center of your circle to each vertex of your triangle, I want you to construct each radius segment. You can use your straight edge if you need to. Now, the nice thing about this is we know that all radii of a circle, they are congruent to each other, because one radius measure of a circle, it has to match up to the same circle's other radius value. So we're going to go and mark those congruencies. And my pencil keeps breaking. Okay, so that's basically it right here. That's all we have. I want you guys now to draw a triangle using your straight edge down here. Don't make it too big, because you're going to need to do two of them.
Does it have to be equilateral?
It doesn't have to be equilateral. I'm purposefully making mine not equilateral. Okay, so I need you to have two triangles constructed. And then we're going to look at incenters. Now, the difference between incenters and circumcenters. One, circumcenters are created by perpendicular bisectors, and incenters are created by angle bisectors, point of concurrency. Two, circumcenters have a circle circumscribed about our triangle, whereas our incenters, that's where we have a triangle with a circle inscribed inside of it. So let's go ahead and construct. I'm going to rough-hand it. This is such a tiny drawing. I'm not going to be able to draw these angle bisectors precisely, but I'm going to try my best to create angle bisectors. So again, bisecting means cutting in half. Okay, so I know that would be roughly like this for me. Your angle bisector is going to look different than mine. Okay, and I am totally freehanding this. It's not going to be perfect. Here's another angle bisector, and I'm trying my best to do this. Again, I'm freehanding it, so it's not going to be perfect. And then with my third remaining angle, I'm going to try my best to freehand it and bisect it. Now, by nature, these angle bisectors, they do meet at a point of concurrency called the incenter. So your three lines should intersect at a point. If not, then you're way off. Every single triangle has exactly one incenter and exactly one circumcenter. It has exactly one centroid and it has one orthocenter. These are just some characteristics of our triangles. Now, because we are working with an incenter, we have those angle bisectors, and we need to go ahead and mark that relationship. So I want you to mark that, this angle here was bisected. This angle down here was bisected. And this angle up here was bisected. You would use a different number of arcs for each angle unless you had an equilateral triangle. But for note-taking purposes, I want you to use a different number of arcs for each overall vertex of your triangle. So I've got one arc down here, two arcs here, and I've got three arcs up here. Okay, and this point here, this point is called the incenter. Now, guys, the incenter is the center of a circle that is inscribed inside of our triangle. Okay. I'm going to try my best over here. I'm going to just kind of freehand my angle bisectors again really lightly because that's not going to be my focus on this one. But I need to get that point of concurrency. So I repeated the process to quickly get that point of concurrency again because this is the center of my circle that is inscribed inside of my my triangle. And now I'm going to try my best to draw the little segments that would drop down from this center in a perpendicular fashion. Okay, I am not good at drawing. Obviously, that's like way off. But if I actually was truly going through the construction process, I would have my exact incenter and I would have a perfect circle that is inscribed inside of my triangle. My circle is a little off, but I tried my best. Okay, so the main reason why I wanted to point this out, though, is because there are little segments that you need to know the relationships about. Okay, y'all, sidebar conversations have got to stop, please. Thank you. Okay, so again, we have some radii values, and they're always going to be perpendicular to that side, the sides of your triangle, and we know they're congruent, so you should mark that relationship. So, in contrast, earlier when we were working with a circumcenter, from the center of the circle all the way to the vertex of the triangle, each of those long segments were congruent, whereas here it's a smaller one to the incenter. And that's because our circle is inscribed inside of our triangle. So that's a key connection. But then we also have those angle bisectors. Okay, and last but not least, I want to make note about what medians, and centroids, what that is. If we were to have a triangle, all a median is it connects from the midpoint of a side to the vertex opposite of it. So I'm going to go ahead and eyeball my midpoints and create one median. Okay, so I have constructed one median. Now I'm going to rotate my picture so I can eyeball another midpoint. I'm going to mark that that bisecting is happening from that midpoint. And again, though, a median, it connects from the midpoint to the vertex opposite from that side. So here's that vertex opposite. I'm going to go ahead and come on down. It's a little crooked. And then that third remaining side, I'm going to construct my last median. So here's, that looks roughly like in the middle. By definition, a median is created by a midpoint that connects to the vertex opposite of it. And that point of concurrency, that is our centroid.
You gotta slow down. I'm like struggling.
The nice thing about medians is that when they do meet at this point of concurrency, the centroid, it gives us a nice ratio relationship. Does anybody remember the ratio? Yeah, there's a 1 to 2 ratio. And so pulling on that 1 to 2 ratio relationship, in total we have 3 parts. 1 plus 2 equals 3. So if we were to take one median, and I'm going to take just one of them right now, I'm going to look at this one. What it's saying is I could take that median, I could divide it in, like if I knew its overall measure, I could divide it by 3. And, this side over here is, twice the size as this side over here. This is a 1 to 2 ratio. Okay, now that I think about it, maybe I should have used this one because that would be 1 to 2 here also, and this is 1 to 2. But the shorter side is half the size as the longer side of your median, about that point of concurrency. Pretty easy. You guys at Smart Goal had this. I think overall most of you did good on this one. It was the first two that kids had a hard time with. So I'm going to have y'all flip over, and we're going to solve a problem. Okay, so on your paper, there are 3 triangles. You have the exact same triangle that I have here in your very first cell. Okay, you guys don't have the words that I have though. So I do want to tell you that this is a circumcenter because it's given to us that way. We have a circumcenter, and I want you to label it that way on your paper because this is for you to have as notes. Okay, so on my side, it says that consider triangle ABC in the figure below. The perpendicular bisectors of its sides are, and it gives me those perpendicular bisectors. It says they meet at a single point G. In other words, G is the circumcenter of triangle ABC. Like it's giving me some key terminology. It's not on your paper. I'm just reading you what I have. You guys have it in McGraw-Hill. Anyhow, it gives us some measures that we're going to go ahead and plug in. It says suppose that EG equals 60 degrees, AB equals 86, and AG equals 100. Before I go and label these measures, what I want to do is I want to go ahead and draw what a circumcenter is. And a circumcenter is a circle circumscribed about that triangle. And if they're, it says their figure is not drawn to scale though. So I'm not going to use my compass because their figure is probably not drawn to scale. I'm going to instead just use these points. And I know that they would line up perfectly on my circle. And I'm going to kind of freehand a circle. Ooh, that's looking rough. But I tried my best. I would have used my compass, but then I saw, yeah, it says figure is not drawn to scale, so there's no point in me doing that. But I do know that G, that is the circumcenter, and so that is the center of this circle that is circumscribed about the triangle. When you guys take your test, you need to know the difference in the terminology. This is what's going to help you get answers correct. Right off the bat, we have our radius values that are congruent. I'm going to go ahead and highlight them. I want you to highlight them as well on your side. If you have not circumscribed your triangle, I need you to do that. And the reason why I'm highlighting it is because each of these measures, they're equal. They're congruent. And that's because we have a circumcenter. Now, also, because we have a circumcenter, we know that each side has a perpendicular bisector. So I know that point D is a midpoint, and it's bisecting side AC. So I know that AD is congruent to DC. Likewise, I know that E is a midpoint, so it is bisecting side BC. So BE is congruent to EC. And last but not least, we know that F is a midpoint, so it's bisecting side AB. So AF is congruent to FB. That is the very first thing you should do on your test and on your SMART goal assessment. You should label what you know when you're working with a circumcenter as far as congruencies. And then you worry about plugging in numbers. It tells us that EG is equal to 60. So I need to go ahead and label that. So EG is this little measure here, and it is equal to 60. It also says that AB equals 86. Now AB is an entire side of my triangle. So I'm going to go ahead and use a bracket to indicate that I have that entire side. And last but not least, it says AG equals 100. So AG, that is this radius value, and it's 100. We're going to look for different measures in this figure. At first, we're asked to find the measure of AF. Can you tell me what the measure of AF is?
It's half of 86 to 43.
Yeah, it's half of 86, so it's 43. So AF is here, and that's half of 86, so it's 43. All right. What about CG? How do you know?
Because it's congruent. I got you.
Okay, so CG is from here to here. It's going to be congruent to AG, so it's 100. So far, have we had to do any hard work?
Nope.
Not really. You just got to know your properties. Okay. The last thing we're going to find is BE. That's going to take a little bit more work. Okay, so BE is right here. And what I strongly recommend is that you pluck off that right triangle corresponding to BE. So this little right triangle here that I've highlighted, I'm going to go ahead and basically take it out of the picture and redraw it over to the right. So I'm going to take this triangle and I'm going to draw it over here. Do we know the measure of GB?
We do, it's 100.
Yeah, GB is 100 because it's a radius value. Okay, now we have to actually solve for BE, and we have a right triangle with an unknown. Whenever you guys start working your review tomorrow, I'm going to ask you, what are the rules of solving for a missing measure in a right triangle? Well, not what are the rules. How do you use the Pythagorean theorem? First rule is you have to have a right triangle, which we have that. We've got that 90-degree angle. So the Pythagorean theorem says a squared plus b squared equals c squared. And the second rule, though, so once you have that right triangle, the second rule is the little c has to correspond to the hypotenuse. And again, tomorrow, when you start your review, which is a 2-day-long review, there's 53 questions. Or I think it's questions. Yeah, 2 days. You're going to be asked to fill in the blank. You know, what does little c correspond to? And you're going to have to say hypotenuse. You're going to have this as a note guide, too. So little c has to be your hypotenuse, and that is the side opposite of that right angle. So I'm going to call that little c. As far as your legs, A and B, it doesn't matter which side corresponds to A or which side corresponds to B. All that matters is that C is your hypotenuse. I personally like to let my unknown side correspond to A. So that's what I'm going to do. And I'm going to let my known measure correspond to B. So I have A squared plus 60 squared is equal to 100 squared. I need to do some basic algebra. 60 squared, that's 60 times 60, which is 3,600. 100 squared, that's 100 times 100, which is 10,000. We need to figure out what A is, and A is being squared, and it has 3,600 being added to it, so we have to subtract 3,600 from both sides of the equation. So A squared equals 6,400. And now at this point, you have to get rid of that power of 2. You guys don't get to have fancy calculators on this. I'm going to expect you guys to do it by hand. So we need to find the largest perfect square that divides evenly into this. And this actually does have one, but you wouldn't notice it right off your bat. What I noticed is this is divisible by 100. So I'm going to break this up as the square root of 64 times the square root of 100. And you can see a 64 is a perfect square, 100 is a perfect square, so both of those are going to simplify. And 8 times 10 is, it is 80. It's not, this stuff isn't bad, but it's also easy to forget under pressure.
So we won't be able to use those.
You can use those ones. Yeah, yeah, y'all can use those ones. All right, we're gonna. Yeah, no, not until chapter 9. When we hit the trig unit, that's when you get those. Okay, we're gonna go ahead and move on to an incenter. So on your paper, your second figure that you have is an incenter. So I want you to label it that way. So we have an incenter. Now, the problem actually tells me it's an incenter. So you will have to read to figure out what type of thing you're working with. It says the angle bisectors of triangle ABC are, and it gives them to me. It says they meet at a single point V. And then it literally says, in other words, V is the incenter of triangle ABC. So your test will tell you it is the incenter, or it is the circumcenter, or it is the centroid. If it doesn't tell you that, it might, I mean, for your SMART goal, it's going to tell you, but on your actual unit exam, it might just tell you angle bisectors or maybe somewhere. It might not give you that term. But anyhow, since we have an incenter, we know that that's created with 3 angle bisectors. So this down here is going to be bisected. I'm going to go ahead and go up to angle B, bisect it. I'm going to go to angle C and bisect it. Okay, there's another thing that happens with our angle bisectors, or not angle bisectors, excuse me, with our incenters. Technically, we have a circle that is inscribed inside of this triangle. It is an incenter. And the radius values of our circle come down and touch each side of our figure with a 90-degree angle. Okay, so if we have that inscribed circle, then we have some more congruencies. We have this is congruent to this, which is congruent to that. So the thing is you've got to be able to pull on, what's the difference between an incenter and a circumcenter? Incenter, the circle is inside of the triangle. A circumcenter, the circle is around or circumscribed about the triangle. Okay, next I'm going to plug in some values because it tells me that UV equals 17. It says that BV equals 18. And it says that angle SAU equals 92. So SAU, that's this entire large angle in this bottom left-hand side of our figure. I wish I didn't use blue, but I did. It's too late now. So this is 92. And then it also says that angle TBV, so angle T, here's T, here's B, here's V. So this angle here, oh wow, I'm breaking everything. I can't use different colors. But this angle here is 24. Okay, we are asked to find the measure of angle TBS. So angle TBS, that's this overall big angle for vertex B. If we know half of it's 24, what's the entire measure? 48. Is there work to be shown here? Not really. The only work that's to be shown is labeling your figure. That's really it. We're asked to find the measure of angle TCV. Okay, so TCV, that's this little bitty half down here. Can we find that? Yeah, we know that this angle A is 92 degrees and angle B is 48 degrees. Could you tell me what angle C is? And then once you find what angle C is, could you divide it by 2? 20. Okay, I believe so. So 92 plus 48 equals 140. Subtract that from 180. And we get 40. So the overall angle measure for C is 40 degrees, and half of 40 is 20. You will have to do this on your SMART goal. You will have to do this on your unit exam. Okay, SV. What's the measure of SV? 17. You would have to know that congruency relationship to do that. We have one last thing and we've got 3 minutes. So flip on over to the, well, you don't got to flip, I'm flipping. It's your third one on your paper. I want you to label that as a centroid. So this is a centroid. And it actually tells us that it's a centroid. And if we have a centroid, you need to know that that's going to intersect at a point that divides our median in a 1-to-2 ratio. So that's what you need to know, that 1-to-2 ratio relationship. Okay, so there are 3 parts in total. Okay, for each median. Bless you. It says that QU equals 39. Okay, and it gives me that V is a centroid. So I need to find Q and U. And it says this entire median is 39 units. Since we're working in that 1-to-2 ratio, I like to take that 39, divide it by 3, and I get 13. So that tells me that each third of this is worth 13 units. So what is the measure of VU? Yeah, it's 13. What about QV? Yeah, 26. That's it. You guys, your SMART goal will be just like what you guys have done today, but you only get 10 minutes. They aren't supposed to take that long. It takes a lot longer when you're talking through it. There's practice problems in McGraw-Hill that have been there that like no one's, I don't think, maybe 2 kids have practiced it. But most of y'all have not. I've got 59 of y'all. And last I checked, only 2 kids have done it. That was last week. So you might look at the McGraw-Hill and practice before tomorrow because that will change your SMART goal. Your SMART goals on this stuff. Okay? All right, please put your colored pencils up.